Hello and welcome to the video on sections 19.2 and 19.3, rational numbers as exponents and simplifying radical expressions. So if we want to start with some laws of exponents, if you can follow along here with me, the first one we have here is x to the power a over b. It can be rewritten in two different ways. We can either rewrite it as this first one here, which is the b root of x to the a power, or we can say the b root of x to the a power. Either way is fine. It's just going to depend on the number values to figure out which one is probably going to work better and make the problem mathematically easier. If we look at the second law here we have of exponents, is we have an x to a negative rational exponent. It's going to be the same as any time we have a variable or a number to a negative exponent. We need to make that exponent positive, and to do so we are just going to technically flip the expression. So that's technically x over 1. So we're just going to flip it and make it 1 over x to the ab, and that makes the exponent positive. Conversely, if we started with 1 over x to the negative ab, we would have moved it to the numerator and it's been x to the ab power. Look at the third law we have here. We have x to the exponent ab, all of that taken to the exponent of cd. So all we do is multiply. Just like if you have x squared to the 5th power, it's going to be x to the 2 times 5, which is x to the 10th. Same thing here. It's going to be x to the a times c over b times d. If we come over here and look at the fourth law we have down, is we have a rational expression. We have x to the ab over x to the cd. And just like if you would have x to the 5th over x squared, we're just going to subtract the exponents. So this would be x to the ab minus cd. The fifth law of exponents here, we have x to the ab times x to the cd, and it's going to be the same way. We had x squared times x cubed will be x to the 5th because we're going to add them. So here it would be x to the ab plus cd. On to the next page, we're going to have a couple examples. We want you to rewrite the first two without rational exponents. Okay, so here in this first one, we are given x to the 1/3 power. So when we are going to write that in radical form, it's going to be the cubed root of x. The cubed root of x to the first, but typically we don't write the exponent if it's a 1. So if we look at number 2 here, we have y to the 2/5 power. Well, if we are going to write this into radical form, we need to know which one is going to be the root and which one is going to be the exponent. Every time the denominator is going to be the root and the numerator is going to be the exponent. The way I remember that is the numerator is up top, just like an exponent is, so it just reminds me that that stays up top. We could have written this as the root 5th root of y squared. Either way is accurate. So if we look at the next two examples, they're numbers 3 and 4. We want to rewrite with positive exponents and simplify. Okay, so we have a negative exponent, so how do we make that exponent positive? Well, we're just going to flip the fraction, write the reciprocal, using a positive exponent. So it's going to become 16 to the 1/2 power. Now we can go a little bit farther, and we know that 1/2 power means we're going to have the square root, because 2 is the denominator, of 16 to the 1st power, which is 16. We know the square root of 16 is 4. So we can actually say that 16 to the negative 1/2 power is going to be 1 over 4. So here if we look at 81 to the negative 1/4 power, we're just going to make that exponent positive by flipping the fraction. So we know that 1/4 power is going to be the 4th root of 81 to the 1st power. And 4th root, if we're going to break up 81, we're going to look for groups of 4. Well, 81 is 9 and 9. And we know that 9 and 9 is 3 and 3. So we technically have 4 3's. So that's what we're looking for. 1 over 3. Look at numbers 5 and 6 where we want to rewrite with rational exponents. So here we have the 9th root of 25. Well, that's 25 to the first power. So we're going to rewrite this as 25, first power, 9th root, 1 over 9. 16 here, or 6 here, excuse me. We have the 6th root of 19, y to the third. So you can break this up to the 6th root of 19 and the 6th root of y cubed. So we know the 6th root of 19 is going to be 19 to the 1/6 power. And now the y is going to be to the 3/6 power. Now 3 over 6, we can simplify. And once again, my writing is not working so well. Slow down a little bit here. We'll erase that and rewrite it. We know is going to be 9. And it did it again. Try this one more time. 19 to the 1/6 power. And now 3/6 is the same as 1/2. So we have 19 to the 1/6 power and y to the 1/2 power. Always look to simplify exponents. So now if we go on to the next couple examples here, we're going to use the law of exponents to simplify on 7, 8, and 9. So if we look at 7 real quick, we have 3 to the 7/10 times 3 to the 2/5 power. So we're multiplying here with the same base, so we're just going to add our exponents. So this is going to become 3 to the 7/10 plus 2/5. Now if I'm going to add 7/10 and 2/5, I need common denominators. So I'm going to need to common denominator, which is 10. So I'm going to need to multiply the second fraction, 2/5, by 2. That'll get us a common denominator of 10. So it'll be 7 over 10 plus 4 over 10, which is 11 over 10. So our final answer is 3 to the 11 over 10 power. We look here, now we're dividing. We have the same base, different exponents, 9 to the 1/2 over 9 to the 1/8. So it's going to be 9 to the 1/2 minus 1/8. So if we are subtracting these fractions, I need a common denominator between 2 and 8. I mean, the least common and the easiest to come up with is 8. So if I multiply the first fraction, 1/2, by 4 over 4, I will get 4 over 8 minus 1 over 8, which is 3 over 8. So we know that my 9 to the 1/2 over 9 to the 1/8 is going to become 9 to the 3/8 power. If we look at number 9 here, we have a number taken to a power that's also taken to a power. So it's 10 to the 5/6, all of that taken to the 3/7 power. So when we have a power to a power, we multiply. So it's going to be 5/6 times 3/7. So if I multiply these two fractions, first thing I'm going to do is I'm going to want to simplify. So I notice that 6 and 3, not cross simplify here, 6 and 3 have a 3 in common. The 3 is going to become a 1, the 6 is going to become a 2. If I continue to look, 5 and 7 have nothing in common, 5 and 2 have nothing in common, 1 and 7, nothing in common matter. So we're going to rewrite this as 5 over 2 times 1 over 7. Now I can multiply straight across and I get 5 over 14. So I can say that this is now 10 to the 5 over 14 power. Number 10. This example is wanting us to use rational exponents to simplify. And then they want us to write the answer in radical notation. So the first thing that we have to do is we're going to have to write this in with a rational exponent. So we know that 8, the 10th root of p to the 8th, the 8th is going to be my numerator. The exponent is the numerator and the base is the denominator. So I have p to the 8/10 power. Well, 8 over 10 could be simplified. We know that they each have a 2 in common. So 8's going to simplify to 4, 10's going to simplify to 5. So it's now p 4/5 power. Now this answer would suffice if they wanted it in exponential notation. They actually want it in radical notation, and I've noticed my 5 looks a little bit like a 6, so we'll clear this up and I'll rewrite this as a clearer 5. There we go. And so we want this in radical notation, so we're going to make our radical, put our variable in there. We know we're going to take the denominator and the numerator and make it the power. And once again, we could have written this to look like the 5th root of p to the 4th power, but it doesn't really matter. We can use either one. I would just leave it as what we had. I wouldn't take that extra step. It's just an easier spot for me to make a mistake. I'm sure it is for just about everybody. So if we move on, we've got a couple more examples to go through here. So we are looking at using rational exponents to simplify. So we're given quite a big radical here. We're looking at the 5th root of 243. The 5th root of 243, a to the 10th, b to the 20th, c to the 15th. So I'm going to want to simplify this. First thing I'm going to look at is the number. So I have 243 here. I need to factor this, to get a little factor tree, and look for groups of 5. So I know that 243 goes into, and it does that 81 times. Well, I know 81 goes into 327 times. I know that 27 goes into 3 9 times. It goes into 9 3 times. So I am looking at 1, 2, 3, 4, 5 3's. So I write this first part as the 5th root of 3 to the 5th power. So I'm just going to spread all of them out. So I want to have the 5th root a to the 10th, the 5th root of b to the 20th, and the 5th root of c to the 15th. And these are all multiplied together, so I can expand it like this. So I know the 5th root of 3 to the 5th is the same as in my 3 doesn't look very good there, so we'll erase it and rewrite it. 3 to the 5 over 5 power, which is 3 to the 1st power, which is just 3. Once again, not letting me write 3's very well. We'll try it one more time. There we go. So I know that the 5th root of a to the 10th is going to be a to the 10 over 5. Well, I know that 10 over 5 equals 2, so this is going to become a squared. Now I have b to the 20 over 5. We know that 20 over 5 is 4, so that'll simplify to b to the 4th power. And that c, once again, tried to write too quick, I apologize for that. C to the 15 over 5, we're just making all these radicals into rational exponents. So c to the 15 over 5, divided by 5 is 3. So it's c to the 3rd power. And this right there, ladies and gentlemen, is my final answer. So the 5th root of 243, a to the 10th, b to the 20th, c to the 15th equals 3a squared, b to the 4th, c cubed. So let's look at number 12 here. We're looking at the 4th root of 32x to the 13th, y to the 5th, and z to the 23rd. So once again, let's start with a number. So we've got the number 32. Looking for groups of 4. I know that 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 2 times. So I have 1, 2, 3, 4. So there's my group of 4, and I have one extra 2. So the way that I'm going to write this is I'm going to write this as, and I went a little too quick there, apologize for that. It's the 4th root of, I wrote a little quick too, the 4th root of 2 to the 4th power, and the 4th root of 2. Well, 2 to the 4th power is 16. 16 times 2 is 32. So that is the 4th root of 32. We just expanded a little bit, so it's a little bit easy for us to deal with. So now if I'm going to look at the variables, and I'll write those here, I know that x to the 13 over 4, I can rewrite that as x to the 12 over 4 and x to the 1 over 4. Using my laws of exponents, if I'm multiplying those, I'm just adding the exponents, and 12 over 4 plus 1 over 4 is 13 over 4. So if I wanted to write these as radicals, I would use the 4th root of x to the 12 and the 4th root of x. So now I have the 5th, which I can write as y over 4. Excuse me, y to the 5 over 4. So I can write that as y to the 4 over 4 times y to the 1/4, and then I can transfer that back into my radical notation as the 4th root of y to the 4th times the 4th root of y. If I go back and look at the z's here, I have z to the 23rd over 4. So I can write that as z to the 20 over 4 and z to the 3 over 4. Once again, I'm applying variables, so I add the exponents. 20 and 3 is 23 over 4. Okay, the reason I'm doing this, and maybe I wasn't all that clear with it, is I want to simplify this as much as possible. And so when I'm looking here at x to the 13 over 4, I want to take out the highest number divisible by 4 in 13. So that's 12. So I've used 12 of them. I have one remaining. Same thing here with y to the 5th, the 4th root of y to the 5th. I want to take out the highest that's divisible by 4, which is just going to be 4, and then I'm left with 1. Same thing with the z. On 23 over 4, I want to take out the highest variable, or the highest number that's divisible by 4 in 23, which that's going to be 20, and then I have 3 left over. And so when I transfer these back, so I know that 12 divided by 4 here is 3. I know 4 divided by 4 here is 1. And I didn't write my z out. I'll write that right here. So we're going to have the 4th root of z to the 20th and the 4th root of z cubed. And we'll try to separate a little bit. And so then if I looked here at the z, I know that 20